Hi students, hello, good morning. This is Kishore, working as a physics lecturer in Vigyan College. So we are dealing the chapter Mechanical Properties of Solids. So in this chapter, in the last section, we discussed the strain and types of strain and also Hooke's law and what is modulus of elasticity. And now in this session, let us see what is modulus of elasticity and what are different types of modulus elasticity and also Poisson's ratio. So let us start the session. So in the last session, we learned about the modulus of elasticity. So modulus of elasticity is nothing but it defined as the ratio of stress to strain and denoted by E. So E is equal to stress by strain. So the modulus of elasticity is nothing but defined as the ratio of stress to strain. It is denoted by E. And there are three types of stress and also three types of strain. So we already discussed in the last section. So like that, there are three types of modulus of elasticity. So here there are three types of modulus elasticity. So first one is nothing but Young's modulus of elasticity, and it is denoted by the letter Y. And the second type of modulus is nothing but rigidity modulus of elasticity, and it is denoted by letter eta. Whereas the third type of modulus of elasticity is nothing but bulk modulus of elasticity, and it is denoted by letter B. So there are three types of modulus of elasticity: Young's modulus of elasticity, rigidity modulus of elasticity, and bulk modulus of elasticity. So Young's modulus of elasticity is denoted by Y, whereas the rigidity modulus of elasticity is denoted by eta, and the bulk modulus of elasticity is denoted by B. So now let us see what is Young's modulus of elasticity and also rigidity modulus and bulk modulus. So the first type of modulus of elasticity is nothing but Young's modulus of elasticity, and the Young's modulus of elasticity is defined as the ratio of longitudinal stress to longitudinal strain, and it is denoted by Y. Or it can also be defined as the longitudinal stress acting per unit longitudinal strain is also called as Young's modulus of elasticity, and it is denoted by Y. So the formula for Young's modulus of elasticity is nothing but Young's modulus of elasticity is equal to the ratio of longitudinal stress to longitudinal strain. So this is the expression for Young's modulus. Young's modulus of elasticity is nothing but longitudinal stress by longitudinal strain, and we already learned longitudinal stress is nothing but force by area. So longitudinal stress is given as F by A, whereas the longitudinal strain is nothing but change in length by original length. It can be written as delta L by L or E by L. So by simplifying it, FL by A delta L. So this is Young's modulus is denoted by Y. So the expression for Y is nothing but Y is equal to FL by A delta L or FL by AE. So this is the expression for Young's modulus. So in this expression, Xp is nothing but force acting on the wire, and L is the actual length of the wire, and A is the area of cross section of the wire, and delta L is the increased length of the wire. So this is about Young's modulus. So it is defined as the ratio of longitudinal stress to longitudinal strain, and it is denoted by Y, and Y is equal to FL by A delta L is the expression for Young's modulus. So this we are observing in this video. So here we are applying a force on the wire, whereas L is the length of the wire, and A is the area of cross section of the wire, and delta L is the increased length of the wire. So in this video we are observing, so F is the force applied on the wire, and L is the length of the wire, and A is the area of cross section of the wire, and delta L is the increased length of the wire. So that is we are observing in this video. So next type of modulus of elasticity is rigidity modulus of elasticity. So the rigidity modulus of elasticity is defined as the ratio of tangential stress to shearing strain, and it is denoted by the letter eta. So the rigidity modulus of elasticity is defined as the ratio of tangential stress to shearing strain. So the formula is given by rigidity modulus of elasticity so is equal to the ratio of tangential stress to shearing strain, or it is also called as tangential strain. so denoted by eta. So tangential stress is given by force by area, whereas shearing strain is given by x by L. So that is the ratio of relative displacement to the perpendicular distance between the layers. So then we get eta is equal to FL by AX. So this is the expression for the rigidity modulus of elasticity. So as we are seeing in this video, so here in this expression eta is equal to FL by AX. Here F is the force acting on the body, L is the length, perpendicular distance, A is the area of cross section, and X is the relative displacement of the body. So the rigidity modulus of elasticity is defined as the ratio of tangential stress to shearing strain, and it is denoted by E. The next type of modulus of elasticity is bulk modulus of elasticity. So it is defined as the ratio of normal stress to bulk strain, and it is denoted by letter B. So the formula is given as bulk modulus of elasticity is equal to the ratio of volume stress, or it can also be defined as bulk stress to bulk strain. And we know the stress is nothing but force by area, whereas strain is nothing but delta V by V. But here we get minus because there is a decrease in volume, that's why we get minus. And the bulk modulus is denoted by B, so which is nothing but minus. So F by A is nothing but pressure, so pressure PV by delta V. So the bulk modulus of elasticity is given by B is equal to minus PV by delta V, whereas the minus indicates that there is a decrease in volume. So this is the expression for bulk modulus of elasticity. So bulk modulus of elasticity is defined as the ratio of normal stress or bulk stress to bulk strain, and it is denoted by B, and B is nothing but minus PV by delta V. Here P is nothing but pressure, which is nothing but force by area. So F by A can be written as pressure, so minus PV by delta V, and here V is the original volume and delta V is nothing but change in volume. So next the compressibility is nothing but, so the compressibility is given as, next we will see what is compressibility. So compressibility is nothing but the reciprocal of bulk modulus is called as the compressibility. The reciprocal of bulk modulus is called as compressibility, and it is denoted by C, which is nothing but 1 by B. So C is equal to 1 by B. The reciprocal of bulk modulus is called as the compressibility. So this is about the bulk modulus of elasticity. It is the ratio of volume stress to bulk strain, and it is denoted by B, and the expression is nothing but B is equal to minus PV by delta V. So watch this video also. So here the pressure is P and V is the original volume, and delta V is nothing but change in volume. So now let us see Poisson's ratio. So watch this video. So in this video we are observing, so whenever there is a rubber band is stretched, so there is a obviously length of increases and also the diameter of the wire also decreases. So whenever a wire is loaded, so length of the wire increases, at the same time the diameter also decreases. So the decrease in diameter is called as the lateral strain, whereas the increase in length is called as the longitudinal strain. So we are observing in the video, so we are stretching a rubber band. So at the same time the length of the rubber band increases, at the same time the diameter of the wire, that means the rubber band becomes thinner and thinner. So which shows that there is a lateral decrease, which is nothing but lateral strain. The decrease in diameter or the decrease in radius is called as a lateral strain, whereas the increase in length is called as a longitudinal strain. Okay, so here the increase in length of the wire is measured as a longitudinal strain, whereas the decrease in diameter or decrease in radius or decrease in area is the measure of lateral strain. So the Poisson's ratio is nothing but is defined as the ratio of lateral strain to longitudinal strain. So here we are observing the definition. So it is defined as the ratio of lateral strain to longitudinal strain, and it is denoted by sigma. The Poisson's ratio is denoted by sigma. This is the letter sigma. So it is defined as the ratio of lateral strain to longitudinal strain, and The expression for Poisson's ratio is nothing but, or the formula of Poisson's ratio is the ratio of lateral strain to longitudinal strain. So lateral strain by longitudinal strain is called as the Poisson's ratio. So denoted by sigma. Sigma is equal to minus. So why minus means the radius of the wire or the diameter of the wire decreases. That's why we're getting minus, divided by longitudinal strain is nothing but delta L by L. So this is expression for Poisson's ratio sigma. Now sigma is equal to minus delta R by R by delta L by L. So Poisson's ratio is defined as the ratio of lateral strain to longitudinal strain, and it is denoted by sigma, and sigma is equal to minus delta R by delta L by L. And the values of Poisson's ratio is nothing but the theoretical values are minus 1 to 0.5, whereas the practical values are 0 to 0.5. So these are the values of sigma. So the theoretical values are minus 1 to 0.5, whereas the practical values are 0 to 0.5. Hi students, here in this section we discuss about the types of modulus of velocity and also Poisson's ratio. So that's it for section. So we'll meet in the next session. Until then, have a great day. Thank you.